Understanding how economic variables relate to each other over time has transformed the way governments make policy decisions and businesses plan for the future. At the heart of this transformation stands Clive W. John Granger, whose groundbreaking work in time series analysis earned him the Nobel Prize in economics and fundamentally changed how we analyze economic data. Born in 1934 in Swansea, Wales, Granger showed an early aptitude for mathematics. His family moved to England during World War II, where he would eventually pursue his education at the University of Nottingham. Initially interested in mathematics, Granger found himself drawn to the practical applications of statistical methods in economics, a field that would become his life's work. Granger's most influential contribution came in the 1980s when he developed the concept of cointegration alongside Robert Ingle. This revolutionary idea addressed a fundamental problem in economics: how to properly analyze relationships between variables that each follow random, unpredictable paths over time. Before cointegration, economists struggled to distinguish between genuine long-term relationships and spurious correlations that appeared meaningful but were actually meaningless. Cointegration revealed that even when individual economic variables wander unpredictably, they can still maintain a stable, long-term relationship with each other. Think of two drunken wanderers tied together by a rope. Each stumbles randomly, but they never drift too far apart. This insight allowed economists to model relationships between variables like income and consumption, or exchange rates and price levels, with unprecedented accuracy. Another cornerstone of Granger's legacy is the concept now known as Granger causality. This statistical test determines whether one time series can predict another. If past values of variable X help forecast future values of variable Y beyond what Y's own history can predict, then X is said to Granger cause Y. This tool became invaluable for understanding economic relationships, from how money supply affects inflation to how stock prices respond to interest rate changes. The practical applications of Granger's work extended far beyond academic journals. Central banks began using his methods to improve inflation forecasts and guide monetary policy. Financial institutions employed his techniques to model asset prices and manage risk. Government agencies applied his frameworks to predict economic growth and unemployment. His work provided the mathematical foundation for evidence-based economic policymaking. Granger spent much of his career at the University of California, San Diego, where he built one of the world's leading centers for econometric research. His teaching influenced generations of economists who would go on to apply and extend his methods. He published over 200 papers and several influential books, each contributing to the growing toolkit available to empirical economists. In 2003, the Royal Swedish Academy of Sciences awarded Granger the Nobel Memorial Prize in Economic Sciences, sharing the honor with Robert Ingle. The Academy recognized their methods for analyzing economic time series with common trends, acknowledging how their work had reshaped empirical economics. This recognition cemented Granger's place among the most influential economists of the 20th century. Beyond his technical contributions, Granger championed a philosophy of letting data speak for itself. He advocated for flexible modeling approaches that could capture the complexity of real economic relationships rather than forcing data into rigid theoretical frameworks. This pragmatic approach influenced how economists balance theory and empirical evidence. Granger passed away in 2009, but his influence continues to grow. Modern machine learning techniques in economics build upon the foundations he established. Climate scientists use adaptations of his methods to analyze environmental data. His concepts appear in fields ranging from neuroscience to political science, wherever researchers need to understand relationships and time-varying data. The tools Granger developed transformed economics from a field that relied heavily on theoretical reasoning into one grounded in rigorous empirical analysis. Every time a central bank adjusts interest rates based on forecasting models, every time a researcher tests whether one variable influences another, the fingerprints of Granger's work are present. His legacy lives on not just in academic citations, but in the improved economic decisions that shape our daily lives. Clive Granger demonstrated that careful statistical thinking could unlock patterns hidden in the chaos of economic data. His work provided the mathematical language for describing how economies evolve over time and how different economic forces interact. Through Cointegration, Granger Causality, and his broader contributions to time series analysis, he gave economists the tools to move from speculation to evidence, from theory to testable predictions, fundamentally advancing our understanding of economic systems.